My name's Clinton Dow. I'm here from the Geoprocessing team to talk about deploying tools as Python modules. I just want to take a quick second to wish everyone a happy International Women's Day. One of my favorite things about the Python community is how all-inclusive it is, so I'm really happy that everyone can be here to talk about it today. And also, I just want to mention there's a session immediately after this as well that I'm doing on Conda packaging, so I'm going to try and end this session just a little bit before 4:30 to allow the transition. So there might not be a lot of time for questions. So if you do have any, I'll be happy to give you a business card and we can discuss that later. So getting into the presentation today, just start to discuss what a Python module actually is and essentially how it can help you when you're creating geoprocessing tools. I do want to be clear that there's also a function in geoprocessing where you can have a Python package as a system toolbox, and that's not what this talk is about. That process is kind of being redesigned with Conda. So we're trying to move away from the current way that that's being done. So a Python module is basically any file that ends in .py, so any Python file. The whole point of breaking things up this way and not having it just in one giant file is that these modules will group the related functions, classes, and the metadata, such as doc strings or just any comments that you need about it as well. That kind of all makes sense to keep together. It's important to also just recognize that there are some naming conventions with Python modules. They're defined in the PEP8 Python enhancement protocol, which is available online. I didn't put a link on there, but I can get that for you if you're interested. So if you just take a look on your left there, you'll see that there's a number of Python files. The first ones up top there start with the underscore. So that essentially means that they're essentially private, and that what we're trying to accomplish with that is just when you're using import statements, all of those will be ignored. So essentially, you're in a way preventing people from accessing it. However, it's not a true private class like in a compiled language like C# or something along those lines. So keep in mind that all of that code and functionality is still accessible, even if it's a private module. And there's just a very important distinction to make between a Python package and a Python module. So a Python package is actually when you have a folder filled with .py files, modules, and then you have an double underscore init file in there as well. And that essentially tells Python that that entire folder has contents that it should recognize. So kind of in line with grouping similar functionality into modules, you want to kind of group related concepts into packages. And if you design your tools this way, then it becomes very easy to interoperate between tools and to reuse code, which I'll discuss later in the presentation. So I mentioned importing in there. Now, import seems like a very, very basic thing in Python, but there's actually a lot going on there, and it's very, very important to understand how that works when you're trying to actually modularize things in the canonical way. So essentially what happens when you import a module is it pulls everything that's in that .py file to the place in your file that that import statement is and executes it. So everything that's in there will be imported into the globals namespace, which you can actually see in Python by typing globals and then open close parentheses. And that'll print out a big dictionary full of all of the names and then all of the related functions as well. So that's important to know because there can, at some points, when you're dealing with multiple tools that have been done by multiple people without any naming conventions, that there's things like namespace collisions that could happen, which we'll discuss later as well. So there's certain ways to get around that. You can essentially use import in several different ways. So the most commonly taught one is just import and then an entire module name. And that works just fine. However, there are some implications about what happens when you do that. I'll discuss that a little bit more in detail later. I'll stick to what I have on the slide here, though. So essentially, when you're importing ArcPy, there's essentially two ways in ArcPy to load a tool that you're probably familiar with. You can either have the tool name and then an underscore and then the actual toolbox that it's in, or you can use ArcPy.toolbox name and then .tool name. And both of those actually do different things under the hood, so it's important to understand that if you're importing the function name underscore tool name, that it'll actually load all of those functions just due to the way that the init.py file works in ArcPy. So if you're wanting to just kind of get a smaller bit of functionality, as I had mentioned in the multiprocessing talk yesterday, that it's actually better in that case to use the ArcPy.toolboxName.function name. So all of those things come in modules. If you're wanting to get to know what modules are a little bit better, it's also good to recognize that they're in fact objects. And essentially, that object contains all of the bytecode that's been compiled when it brings that file in during the import statement and then runs it. So you can essentially control a little bit about what people can see on those objects and therefore what they can do with Python with the $_all variable that would be at the module level, and that is essentially just a list of strings that exposes everything in that module. For example, to things like autocomplete, IntelliSense, that sort of thing. So you may notice if you're using arcpy.da in Visual Studio or PyCharm or something along those lines, it currently doesn't autocomplete. And the reason for that is that arcpy.da is a compiled C class and therefore doesn't have an all in the module. So it basically can't talk to Visual Studio and let it know what's going on. So that's something that we're looking at improving here in the near future and just getting that to work with all of the IDEs that are available. Now there's also the import lib pure Python module, and it was just introduced a while ago in Python 3.1. So if you look through a lot of the ArcPy code, which was done prior to that, we were using the imp module, which does similar things, but there's a little bit of different machinery under the hood that just makes import lib a little bit safer to work with. So I definitely recommend, if you're going forward and looking at doing that, that import lib is definitely the way to go. And it's one of the few ways that you can actually easily get a module object that you can, at that point, start exploring with inbuilt functions like dir, which will expose everything that's actually in the module, including the private members. And at that point in time, you can actually begin to see how the functions correlate to the dictionary keys in there. So there's a few best practices just for using import in the best way possible. So it's basically just break all the functionality down into small modules. So when you're importing something, it's not bringing a giant file up and running that all. It's just doing little piecemeal functions. Also, you can control the loading of multiple modules in the init_init.py file. So you don't necessarily have to expose everything that's in there. You can have that only exposed via the actual module. But if you want to have an extra level, kind of an interface, so to speak, then you define that in the package. And also, if there's a kind of consideration with how the tool is going to be used. If it's something that is only going to be used internally and you're not sharing outwardly, then you can be pretty safe that you're not going to have many namespace collisions at that point in time, as long as you're mindful to not collide with any of the packages you're consuming. However, if it's going to be used by other people and possibly put into a larger data pipeline or something along those lines, then you also have to be mindful of both the downstream and upstream consumption of it. So try and use specific names for things if at all possible, and also control as much access to them as you can with the underscore. So just a few other things here to follow up with. So there's also import lib. If you're writing Python in an IDE, you'll notice that it always tries to tell you to put all your import statements right up at the top, and that's actually part of that Python enhancement protocol, PEP8. And that's just basically, it makes it a lot easier for people to just at a glance see what you're importing and try and anticipate those namespace collisions. However, if there's a very important part of your functionality is the lazy loading of modules. So, basically bringing something in midstream of your program only when it's required. Then import lib is definitely the best way to do that, because you won't have any of those issues. Although I would definitely recommend just mentioning that in the doc string that you're loading something further down in the actual module. And yeah, so as I mentioned, no one wants to kind of be in this situation. It is entirely possible where there's actually two packages or modules that start to get used very frequently by different groups, and then eventually they start to merge. And if those have both used very generic names, then you have this kind of situation where whose fault is it? Who's going to pay the debt, so to speak, of fixing things, and what implications is that going to have on the rest of the life of that package? And in some cases, it can actually be fairly intense. So you might be wondering why, as a GIS developer making tools, you should care about any of this stuff. It's fairly in-depth Python, so maybe not something that you'd use when just writing a fairly simple geoprocessing tool. But what happens when you start to modularize is you're basically building yourself a library of functionality that is very well designed. And if you go into a library and there's just all these bookshelves everywhere, you don't really know where to go. But if you have them all well labeled and everything, then you know exactly where to go. So it's the same kind of idea, developing your own code library in that case. And then if that can be done across an entire organization, you can, of course, begin to share these functions with everyone. And every time someone's using a function that already exists, that means they don't have to write that again. So you're saving, it might be 5 minutes, it might be 5 hours, but that's time that you're not having to pay out and essentially able to use for other productive work instead of reinventing the wheel. So what I like to encourage to facilitate that is to just regularly refactor your code. I'm not sure how common it is, but a fairly common, in my world at least, expression called Technical Debt Tuesday, where you basically just take Tuesday and try and refactor stuff and make it run better, and just kind of get everything in a very nice and usable state. And if you can do that again as an organization and have a little bit of communication within that, it really opens things up and allows rapid development and a lot of cross-pollination of ideas that might not otherwise be apparent to people. So I tend to like to think of in my opinion at least, and there's definitely many opinions out there, so take it with a grain of salt, but the best way to break them up, in my opinion, is to kind of have this actually 4-layer type of approach. It's a little bit contrary to, for example, if you're coming from a C# or WPF background, to their 3-layer model view model approach. This is kind of the same idea, but essentially you have one package or one suite of modules that handles your data. So that could be anything from working with file geodatabases, REST endpoints, GeoJSON, or you name it, and have that all modularized so that can just be swapped in and out depending on what you're actually wanting, which type of data you're wanting to utilize with your tools. Likewise, with the functional model, that's just where all of your functions would go. So it's very similar to a toolbox in that respect. The view model at that point, now this gets a little bit outside of developing in the application, but it's essentially also considering things like endpoints. If you're wanting to indicate that something's been done, you also have to have code that kind of reacts to the fact that the data's finished loading or something along those lines. So it's basically the code that tells the interface that something is ready to go and to indicate that that's the fact in some respect. And then lastly, the view, which is actually the window that you're looking at things in and all of the toolbars and everything along those lines. So if you can try and share those as much as possible, then it really enables people to pick and choose what they want out of pre-existing stuff and save a lot of time. Also, it's quite self-documenting in a way, because once people realize that their code's going to be used elsewhere, then it's a very motivational thing that it'll be documented a little bit more clearly and commented on a little bit more clearly as well. So it's as much a cultural shift as it is just a programming shift, I would imagine. And I've already mentioned, don't reinvent the wheel. A lot of this functionality probably exists out there in packages as well, so it saves a lot of time even to just do a bit of research up front and essentially get to know the Python ecosystem in depth. Another benefit is testability. Out of curiosity, does anyone in here do test-driven development? Show of hands? Not really, yeah. A few people, yeah. So that's good to see. It's not super common, but it's a very powerful idea in that you're essentially creating the tests first. And the whole reason for this is because there's a lot of side effects that can kind of creep up as you're developing and putting little things in, and it can just essentially change the whole flow of your program unintentionally. So if you have those tests done up front and you're running the modules in very small increments against the tests, then you're essentially making it a lot easier to find where those side effects are happening, to make the debugging experience a lot better, and so forth. There's also, so the two types of testing that this encourages is unit tests. So the unit tests are more of the individual units of functionality, so where you're taking a single function and trying to test those edge cases to figure out where the side effects may crop up. And also integration tests, where you're basically testing the interoperation between those individual units of functionality, and that you would also want to be fairly thorough so that essentially the bugs that can crop up when things are talking to each other are also identified. Again, just kind of interchangeable. It's a lot easier to kind of comprehend what's in a small book than it is to try and comprehend what's in War and Peace. And basically it's the same idea with modules. If you've got 20,000 lines of code and someone needs to figure out what that module does, they've got 20,000 lines, give or take, worth of information to process rather than maybe only 20. This also allows quick prototyping too. So if you just want to take a little piece out, try a new thing, you're not having to consider its entire effects on that giant book. It's more so just how is it a few pages. So the best analogy I can give for that is it's similar to building something with Lego versus building with concrete. You can take little pieces off, put a new piece on. You don't like the color of this, pop it off, put it on. And it's just a lot easier than having to go through the whole redesign process of an application. So I won't spend too much time on this one, but it's essentially when we're talking about developing tools, this becomes powerful for a number of other reasons that aren't just in pure Python. And basically, when we're working with geoprocessing tools, there's a number of ways that we can access those, like .tbx toolboxes, .pyt Python toolboxes, the Python window in the application, and also straight from the command line. So essentially, if you only write the actual logic of the tool one time, then all you have to do in each one of those things is import that logic and then essentially pipe the parameters through to the function. And then that can be reused over and over again. And it also means that you can start chaining them together a lot more easily without having to consider all of the data validation steps that come within it. So essentially the two types of toolboxes they're quite different in that TBXs, as I'm sure you're aware, are just accessed through the geoprocessing pane in the application, and PYT are all done through Python code within the toolbox. So it can basically all be encapsulated in a single module at that point in time. So I'm just going to jump over to the application here and quickly show you what I mean by that. So just over here in toolboxes, you can see that there's this run species distribution model present in both the Conda. Oh. All right, so essentially on the far left there, you can see that there's the two types of toolboxes, the PYT and the .tbx, and those are both accessing the same actual script file under the hood. I can't really, there we go. Sorry, just 1 second. I'm just pulling this up here. There we go. So they're both essentially using this classifier.py, and at that point in time, each one has the validation steps as well that will basically ensure that the data that's going through to that function is what it needs to run. So some future enhancements that we're hoping to add is just an easier debugging experience that also utilizes modularization in that it's going to be driven by the Python debugger, or PDB, which is shipped with Python. So that in and of itself utilizes imports in a very concise way to ensure that it's only debugging the things in the modules that you're specifying. All right. Okay, so I'm more or less finished, so I've got about 5 minutes before the next presentation starts. So if there are any quick questions, I'd be happy to answer them. I'll bring over a microphone here as well so everyone can hear. I think.
Hello.
Oh, there you go.
Do you recommend using a virtualized environment for your toolboxes?
Yes, certainly. That's actually what the next talk is about in a large way. Virtual environments or Conda environments are perfect for doing this type of work. It not only allows you to modularize your code in that respect, but then also to modularize it in the actual workspace that you're working in. So it's kind of essentially doing the same thing, just at a higher level.
Can I sort of start up the topic? What is the big difference between Conda? I didn't know it before I came here. I used the virtual environment, also the old code from the Python library, or the old module.
Yeah, so virtual environments haven't gone anywhere. There is still certainly a viable option. Conda is just a full package manager, so it also handles the dependency chains and everything like that in the environment. So if you're installing a package through Conda, like you actually type conda install just as you would pip install something, and it'll handle all of the dependencies and make sure that environment basically, just works on anyone's machine that imports it.
I think that's all.
Looks like it. Thank you.